Learning about uniform motion and non-uniform motion. Uniform motion and non-uniform motion. A body has a uniform motion if it travels equal distances in equal intervals of time, no matter how small these time intervals may be. Consider an object moving along a straight line. Let it travel 50 kilometers in the first hour, 50 kilometers more in the second hour, 50 kilometers in the third hour, and 50 kilometers in the fourth hour. In this case, the object covers 50 kilometers in each hour. As the object covers equal distances in equal intervals of time, it is said to be in uniform motion. The time interval in these motion may be small or big. In our day-to-day life, we come across motions where objects cover unequal distances in equal intervals of time. For example, when a car is moving on a crowded street or a person is jogging in a park. These are some instances of non-uniform motion. Measuring the rate of motion. If a car is running slow, we say that its speed is slow. And if the car is running fast, then we say that its speed is high. Thus, the speed of a body gives us an idea of how slow or fast the body is moving. We can define speed of moving body as follows. Speed of the body is the distance traveled by it per unit time. Different objects may take different amount of time to cover a given distance. Some of them move fast and some move slowly. The SI unit of speed is meter per second. This is represented by the symbol ms to the power -1 or meter per second. The other units of speed include centimeter per second, cms to the power -1, and kilometer per hour, kmh to the power -1. To specify the speed of an object, we require only its magnitude. The speed of an object need not be constant. In most cases, objects will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in terms of their average speed. The average speed of an object is obtained by dividing the total distance traveled by the total time taken. That is, average speed is equal to total distance traveled divided by total time taken. If an object travels a distance s in the time t, then its speed v is equal to s divided by t. Example: an object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. What is the average speed of the object? Total distance traveled by the object 16 meter plus 16 meter is equal to 32 meter. Total time taken is equal to 4 seconds plus 2 seconds is equal to 6 seconds. Average speed is equal to total distance traveled divided by total time taken. That is equal to 32 meters divided by 6 seconds. That is equal to
5.33 meter per second.
Therefore, the average speed of the object
5.33 meter per second.
speed with direction. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. The quantity that specifies both these aspects is called vector quantity, for example, velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion, or both. In case the velocity of the object is changing at uniform rate, the average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity divided by 2. Mathematically, VAV is equal to U plus V divided by 2, where VAV is the average velocity, U is the initial velocity, and V is the final velocity of the object. Speed and velocity have the same units, that is, ms to the power minus 1 or meter per second. Example: the odometer of a car reads 2000 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in km per hour and meter per second. Solution: distance covered by the car S is equal to 2400 km minus 2000 km. That is equal to 400 km. Time elapsed T is equal to 8 hours. Average speed of the car is VAV is equal to S divided by T. That is equal to 400 km divided by 8 hours. That is equal to 50 km per hour equals to 50 km divided by hour multiplied by 1000 meter divided by 1 km multiplied by 1 hour divided by 3600 seconds. 1 hour divided by 3600 seconds. That is equal to 13.9 meter per second. The average speed of the car is 50 km per hour or 13.9 meter per second. Example: Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. Solution: total distance covered by Usha in 1 minute is 180 meter. Displacement of Usha in 1 minute is equal to 0 meter. Average speed is equal to total distance covered divided by total time taken. That is equal to 180 meter divided by 1 minute. That is equal to 180 meter divided by 1 minute multiplied by 1 minute divided by 60 seconds equals to 3 meter per second. Average velocity is equal to displacement divided by total time taken. That is equal to 0 meter divided by 60 seconds. That is equal to 0 meter per second. The average speed of Usha is 3 meter per second and her average velocity is 0 meter per second. Rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of an object for any time interval is 0.
V is equal to 50 km per hour. U is equal to 50 km per hour. So V minus U is equal to 0.
However, in non-uniform motion, velocity varies with time. It has different values at different instants and the different points of the path. Thus, the change in velocity of the object during any time interval is not 0. Physical quantity called acceleration is a measure of the change in the velocity of an object per unit time. That is, acceleration is equal to change in velocity divided by time taken. If the velocity of an object changes from an initial value u to the final value v in time t, the acceleration a is equal to v minus u divided by t. This kind of motion is known as accelerated motion. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity.
The SI unit of acceleration is meter per second square.
If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. The motion of a freely falling body is an example of uniformly accelerated motion. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. For example, if a car traveling along a straight road increases its speed by unequal amounts in equal intervals of time, then the car is said to be moving with non-uniform acceleration. Example: starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. Solution: in the first case, initial velocity u is equal to 0. Final velocity v is equal to 6 meter per second. Time t is equal to 30 seconds. We have a is equal to v minus u divided by t. Substituting the given values of u, v and t in the above equation, we get a is equal to 6 meter per second minus 0 meter per second divided by 30 seconds. That is equal to 0.2 ms raised to the power minus 2. In the second case, initial velocity u is equal to 6 meter per second. Final velocity v is equal to 4 meter per second. And time t is equal to 5 seconds. Then a is equal to 4 meter per second minus 6 meter per second divided by 5 seconds. That is equal to minus 0.4 ms raised to the power minus 2. The acceleration of the bicycle in the first case 0.2 ms raised to the power minus 2, and in the second case it is minus 0.4 ms raised to the power minus 2. Summary. The speed of an object is the distance covered per unit time, and velocity is the displacement per unit time. The acceleration of an object is the change in velocity per unit time. That is all in this topic, students. Let us learn about graphical representation of motion in our next topic.